This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
On today's show,
You'll know how to make your own Growduino.
welcome to Know-How. It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Ballas here.
And I'm Brian Burnett.
And for the next 30, 40, however many minutes it takes, we're going to be showing you some of the projects that we've been geeking out to so you can take them home and geek out on your own. Hippo!
Padre.
How you be?
I'd be good. I'm feeling a lot of energy for this show today.
Right? It's just a little something, something.
Right. I think it's the 6 cups of coffee I already had.
It could be. You're vibrating a little bit.
I saw a hummingbird go through the studio, and it actually slowed down.
It's like, too slow, too slow.
Yeah.
If the studio sets on fire, you can just run around and take
and put it
out,
out.
right?
Yeah, exactly.
That's how that works.
This is totally a Futurama
This is totally,
reference.
yeah, if you don't know what this reference is to, it's your fault.
So we're working on a Growduino today.
We are. Now, people were expecting the oscilloscope, and we will be bringing them the oscilloscope.
Oh, yeah.
There was a little scheduling thing.
Conflict?
It was totally not on Smitty. It was completely on me.
Oh.
So we will be bringing you that, but we do want to do the Growduino. This is something I've been promising for a while. Do you remember that project I made not too long ago? Never made it on the Know-How, where it was an automated watering system.
This sounds really familiar because the end result sounded like a disaster.
Okay, yes, the mechanics were working just fine. Somebody, I don't know who had access to the source code, may have flipped a bit. And my automated watering system, instead of providing 95% pure water and 5% nutrients, was providing 95% nutrients and 5% water.
I don't see why that would be an issue.
Plants don't
that
like
just
that.
means they grow faster, right?
Plants really don't
No.
like that. But we are going to actually show you how I built it. The programming was, everything worked fine. It was just, we need to fix the code.
Okay. Well, it was working all right. It just was over a period of time. Something happened, right? Like something got triggered, or?
Yeah, I'm pretty sure I did a buffer overrun.
Yeah. Okay, that could be it. Because you had said that for a while it was working fine, and under close observation it was all right, and then you left it alone for a week or something, right?
And that's what freaked me out, because I couldn't replicate it. I'm like, I have no idea how this happened, because I didn't write the system to keep really good logs. It basically just told me when it turned things on, not why it turned things on.
Right.
And what I found out was it works fine for 29 days. On the 30th day, like a value just goes over what it should be, and it just went bleep.
Oh, wow. Yeah, that's a little disastrous.
Test your code, people. Test your code. And actually, the worst thing about it was the way that I had programmed it, it wasn't like I could push the clock forward 29 days and watch it happen. It had to actually run for 29 days.
So was it was like it was adding it up, like the data was
I was just really disgusted with what I did, so I just basically trashed. I'm like, I'm gonna write this from the start, because it was
that's how upset you were.
I was really ticked off, because I mean, it was a noob mistake, and it was one of these things where it's like, it destroyed an entire garden.
You know what that means?
A garden.
Unfortunately, plants had to suffer for your knowledge to learn from your mistake, right?
Not for my knowledge. For your knowledge.
Who are you talking to?
It's the fourth wall break.
Oh, right.
It's like a fourth wall break within a fourth wall.
That's like 16 walls.
Wow. Okay, now let's get to it. So what we want to do is we want to start creating a project that will allow us to control how much water and how much nutrients are added to a garden at any given time. Now, this is going to be comprised of multiple parts. We're going to tackle the first part today, which is, how do I store stuff and then release it when I need to release it?
Right. Yeah. Okay, cool.
There are systems out there that will do this, but the cheapest I've found was about $100, and I mean, they run into the thousands of dollars. So if we can get a decent system that we can build for like $50, that we can expand as we desire, I think we can call it a success.
Yeah, and I think this is the kind of project too where it doesn't have to be water. It could be some sort of other project where you're opening a door or something like that.
Right.
You know?
Yeah.
Cool.
The first thing we're going to need, Brian, is a solenoid valve. A solenoid valve. Now, this is a way for us to turn some sort of electrical condition into a physical condition.
Okay.
In this specific case, this is what the solenoid valve looks like. This is from Adafruit. This is their H2O solenoid valve. This thing's going to run about $8. Yeah, pick one of these up from Amazon or go directly.
It looks like it's just a stepper motor attached to a piece.
It's what it looks like, not exactly, but the same principle. So the idea, if you go to the side view here, is this thing up top is essentially an electromagnet.
Oh, cool.
That's really all it is. That's all it does. So when I apply power, and it doesn't, there's no polarity here. I can apply power either way, but I need to give it 12 volts. This will run down to about 9 volts, but it's iffy operation at 9 volts. It really wants 12 volts. It creates a magnetic field, and inside here, there's actually a little rod that gets pulled up. And when you pull up that rod, it's going to activate this valve. So this is a, oh, you can't really see it. Oh, that's that arrow?
Yeah,
so the
shows
flow,
the direction.
The flow is going to go from here to here. It will only go in one direction. But when I give it 12 volts of power, it will turn it on. Now this requires 3 psi, so 3 pounds per square inch in order to activate. A lot of solenoid valves are like that. And actually, you know what we're going to do? Let's go ahead and open this thing up so you can actually see what's inside of it. Because these are fascinating devices. You're going to find them everywhere, especially in irrigation systems. But anytime you have computer-controlled something that's not a huge amount of pressure that requires you to actually have like an actual full-on valve that's connected to a motor.
Right.
You know, they're typically going to use solenoid valves. And these solenoids are also used for things like locking doors. Anytime that you have a simple motion going from one side to the other, these work really well.
Is it variable? Can you adjust how much it opens or closes, or is it just like on-off?
Basically on or off. There are those that you can like choose multiple positions. They tend to be expensive, and I have never really experienced
much success
good
with
results.
Them?
Yeah, you can do it. So this is what it looks like on the inside. Again, this, you'll notice, there's no moving parts in there.
Because it's just a magnet, right?
It's just a magnet. You turn this thing on and it creates an electromagnetic field. What that electromagnetic field does is it affects, there's a little piece of ferrous material inside of here, and it will actually move it from down there to up here.
Down there to up there.
Right there. So if I pull this, this is what it looks like. So the diaphragm is, if it's pushed, if it's in its regular position, it will not allow water to flow from there to there.
Oh, okay.
But if I pull that piece up, what's going to happen is water can now go from that side to that side. And if you look inside here, you'll see how that works. See, so from this inlet, it goes into the center section. And as long as that diaphragm is down, it will not exit through this side.
Right, but then once you apply power, it will move and then water can flow through.
Precisely. So that's essentially what a solenoid is. What I like about this is it's simple. Simple is good because simple means it's going to work more often than it doesn't.
Be reliable, and as long as your code is...
Precisely. About the only thing that's going to mess this up is if you get debris in here, which is why, if you look on this side...
Little filter?
Yeah, these little valves, they've got a little steel filter so that keeps those particles from coming in. If your solenoid does stick, 99% of the time it's because you got a little bit of debris in there and not...
And then, well, like you showed though, it's pretty easy to take apart if you need to diagnose it.
Super, super simple. Now let's show you how these actually work in practice. In practice,
another one?
I've got a lot of these things.
Dang.
Yeah. Hey, because I'm a baller like that.
Yeah, rolling in the solenoids.
We're going to do something that I would not suggest the kids at home do because it requires you to put your life into the hands of somebody else.
Right.
You're actually going to have the power to electrocute me. Normally it's the other way around.
Yeah, wow, this is a very strange role reversal for me.
Super strange. So what we're going to do, if go to the side here, we're going to set...
I hit the button right now.
Stop. So we're going to... Oh, let's before. We're going to set this for 12 volts. It doesn't have to be exact, but there we go. Okay, so 12 volts.
That helps my OCD.
What you're going to do is you're going to go ahead and flip the switch. I'm going to provide 3 pounds per square inch of pressure onto this valve because otherwise it won't open.
Okay, how are you going to do that?
Because here, if you watch, I'm just going to do this. If I turn this, nothing happens
because there's no pressure.
There's no pressure. So
I'm
gonna blow real hard, Brian.
This is the weirdest know-how ever. How did you kill your co-host? Oh, he was blowing on a solenoid and he electrocuted him.
Okay. All right. So go and go to the wide shot here. So
flip the switch. Right now, I flip the switch. Okay, I'll flip the switch. Oh, gross. I guess I was asking for that.
Yes, you were.
Oh, man. It got everywhere.
I know. Well, because I forgot I had actually used this for the morning test.
I think it's in my coffee now.
Probably. Okay, but See, quite simply, let's do it the right way now.
Okay.
Okay.
Right.
So as long as you're providing it with a little bit of pressure on the outside, when I provide 12 volts, that solenoid, it's going to pull that diaphragm out of the way,
Right.
and then I get flow through there.
Right. You just need the pressure to. Yeah.
I could use this for gas. So
You just did.
I just did. I mean, I've got a CO2 system that I've been building. But if you're going to be using high pressure gas, you probably want to use the brass fitting, not the PVC
plastic
fitting.
ones.
Yeah.
That makes sense.
I guess that's a bad thing.
Right.
Yeah.
Right.
I'm not 100% happy with these because that 3 psi actually turns out to be quite a bit of pressure. We'll see. I'll show you why. All right. Now the next component that we're going to need is we're going to need a place to put the liquid.
Okay.
And I didn't want something really expensive, so we went back to our old standby, our good friend,
Mr. Bucket.
Mr. Home Depot bucket.
Yeah, we've used this quite a bit. What was it? The swamp cooler was the last
Swamp
project we did?
cooler. I've done a couple of projects for hiding electronics. I did a Wi-Fi access point in one of these things.
We did the plant.
We did the plant, right?
That smelled really
They're
bad
cheap.
after a while.
They're everywhere, and I mean they're pretty much indestructible for what we're going to use. What we want is we want to be able to fill this up with water. And then we want to be able to release that water or any other fluid, like, for example, a nutrient solution, when we apply power to the solenoid.
Makes sense.
Yeah, super simple. Yeah.
And the amount of water in this bucket will be enough pressure to force the valve open?
Correct. So I did a quick measuring. This will provide more than 3 psi all the way to the point that it gets down to about a third.
Okay.
When it hits that third,
Then
it's iffy. Once it's down below a third, it won't open anymore.
Yeah, so you can just set a marker or something like that.
Right. Now, that's the reason why I'm not super happy with this, because it means the lower third of the bucket I really can't use.
Right.
That's a pretty big design flaw. I've worked that problem out, and I actually have a couple of other solenoids coming in that I can test out. The nice thing is I've made this thing modular so that I can replace the valves as new parts become available or as my demands change for the project.
That is so you. You make everything modular.
That's what I like, because we're going to, I mean, you've seen us. We pull stuff back in. We use it
absolutely.
again and again. All right, so the first thing that we need to do is we need to get a way to put a hole in this bucket without all the water leaking out.
All right, so
That's a problem.
Power drill, right?
Powered, yeah, we're going to drill this thing, but we got to drill it in a very specific way with a very specific valve. My first idea was just to use a bunch of loose fittings. There's like little 99-cent fittings, and then put a bunch of silicone sealant around it, which
JB Weld or something.
It worked. Totally not elegant, but the bigger concern for me is when would I be using a system like this?
Right.
When I'm not home.
Right. You don't
when I
want to
go
leak.
away for a month. And if I create a system that has the potential for leaking just because of the way it's constructed, it's probably not a good idea.
Yeah, exactly. When you come back and then everything's destroyed, your carpet and stuff.
Right.
Yeah.
Especially since the difference between getting the right fitting and the wrong fitting is probably a $10 thing.
Okay, so a $10 thing.
We do a $10 thing. So this is what we got. This is called a bulkhead fitting. This is specifically designed to go through a pressure vessel.
Okay.
Okay.
It looks pretty large.
It looks pretty large, and actually, believe it or not, this is the most expensive part of this project.
And how much is it?
By far. This is like $13.
We can't afford that project.
We can't afford
We don't
that.
have room in the
I
budget
know,
for
I
this.
know, I'm rolling in it now.
First your solenoids, now your bulkheads.
Yeah,
What
I know,
next?
I know. But look here. So take a look at this. This is inside. This is 1/2 inch. On the outside, it's 3/4 inch.
Okay.
Okay. But the real reason it works is because
Got a
of
gasket.
this. Yeah, it's got a gasket. This little black rubber thing that you see. It will allow me to press up against a hole in a pressure vessel, and then I can put this on the other side. So let's just say the tank wall is right there, and then I can tighten this thing down. And by the way, this is reverse thread, so that turning it the way that you would to tighten a fitting.
So righty loosey, lefty tighty.
Right, exactly. And they did that just so that when you're tightening a fixture to it, you're not also loosening the bulkhead
Makes sense.
fitting, because that would be bad.
But that looks like it's made for a flat surface. Is that going to be okay for a curved bucket?
Very, very good. That's going to be our problem, because this is plastic.
You could just tighten it down really, really hard.
I could tighten it really hard and it would probably work, but I will be creating so much stress on the areas that are around the bulkhead fitting that eventually it's going to break. And it's probably going to break when the bucket is full, because that's when there's the most pressure on it.
Right.
And if that breaks, there is no way to stop it. It's at the bottom of the fitting, and if I'm not there, it's going to be all over my floor.
Yeah.
Probably not a great idea.
All right, so this is garbage. Get rid of it.
I know, throw it away. No.
Done.
The other thing we could do, super easy. I could actually put this at the bottom. This thing is flat surface on the bottom, and actually it would be better because if you put it on the side, see where the inlet is, there's a level of water below it that I actually don't have access to.
Right.
Okay. Problem with putting it on the bottom
Filter
is how am I gonna hold the thing?
You could
doesn't-
hang it, couldn't you? Like,
Yeah,
hang
you'd
it
have
from
to
the
hang
ceiling?
it. You'd have to hang it. But I mean, I don't want to do that.
No.
So what I'm gonna do is I'm actually gonna put it on the side, and then I custom design a few things.
Custom, you say? 3D print?
3D printed, Brian. Alex, let's take a gander over to my computer. So the first design I tried to make was this. Super simple. I made a 3/4 inch hole in the middle of its oblong cylinder. This kind of worked. It was not bad.
Yeah.
Not great. Here's the problem with doing it this way, and I only learned this after a lot of trial and error. When we look at what the 3D printed parts look like, go to the side here, it's sort of a perfect curve.
Right.
But inside this bucket, we don't have a perfect curve. This is a tapered bucket. It goes from a larger cylinder up top to a shorter cylinder down below.
Oh, right.
And so what's going to happen is when I put this thing inside the bucket, it
the
looks like
going to change.
Yeah, exactly. The angle changes. It looks like it matches up.
Yeah.
But at the back, it's lifted off the bottom. That's not good because I want to make it a nice tight seal against the bucket.
That's tough.
I did this a lot. I tried a couple of different designs.
Wow.
Not
Yeah,
good.
to find the right amount of taper on that?
Yeah. So I cheated. And what I did was I went to Thingiverse.
Somebody had already done it?
Well, no, but the
Okay.
good people at Thingiverse, somebody made this. If you look at this, that's the bottom of a bucket, a 5-gallon bucket.
Smart.
And so I used that. I turned that into a hole, and I put that over the top of my design. And so what it did was it actually carved away the parts that shouldn't be there.
That's
and then
perfect.
What it came up with was this. So you'll notice, I don't know if you can
Oh,
see
those
it.
are much different.
So I've got my interior seal and my exterior seal. They're hollows of each other.
Right.
So look how different the taper is on those
Yeah.
things. And this actually fits perfectly. Let's go ahead and chisel these bad mamma jammas out of here.
Cool. I'm guessing that the bucket's shaped like that too, so that they can be stacked easily.
Right. If you had the same size of the cylinder on the top as
Yeah,
on
you
the
wouldn't be
bottom,
able
you
to-
can't stack the bucket. Right. But now, when I go ahead and put these things in, it's a perfect. Let's do it this way. It's a perfect fit, and it will.
So easy to
Jeez.
show.
It's hold on.
Maybe
at
you
the
could
bottom.
show the outside one.
Wait. There we go.
Whoa.
See, there we go.
Whoa.
And yeah, actually, the outside one's probably a lot easier.
It was worth
So
the
when
wait.
I do this, actually, there we go.
There you
When
go.
I do it that way, it's going to give me a
Boom.
nice tight seal all the way around the area that I need.
Solid. I like it.
Yeah. So all I have to do now is drill, and then I'm going to be able to put a little bit of silicone sealant on my 3D parts, and then I'm going to use this itself to tighten them together, and then they're going to sit for 8 hours, and that will give me a nice tight seal. Something I do want to notice here, though, is if you
Yeah.
look at this, you'll notice the parts are not smooth.
No. Is that because of the resolution that you used?
No,
or-
that's because originally I did make them perfectly smooth, and I got a horrible, horrible seal.
Oh, right, because there's probably nothing for the sealant to adhere to.
It was basically when I tightened it, I squeezed all the sealant out of
That
this area.
makes sense, yeah.
So what I did was I roughened it up, and that allows surface area for the sealant to attach to. And if I was really doing this right, I also rough up the inside of the bucket and the outside
Right,
of the
right,
bucket.
right.
I didn't do that because
Well, you'll probably get
lazy.
a good enough seal. As long as you make it tight, it should be good.
yeah, just keep it tight and then keep it dry for about 8 hours, and this thing it seals up really, really nicely. In
Nice.
fact, on the version I have now, I am getting a leak. I'm not getting it from this. I'm getting it from the adapter I plugged in. I need a little Teflon tape.
I see.
All right. So we've got this. All we need now is our trusty little Sharpie.
Ah,
This is going to get loud, Brian.
What?
Just FYI.
do you-
Sorry about that. Where do you want the hole? How about on this side?
sure.
Let's do this. Okay. So what we're going to do is we're going to make, because I've made this the right size for my bulkhead fitting, I'm going to go ahead and draw a nice, neat circle around the inside.
Is this the loud part?
No, again, no. And now I can see it from the outside.
So if you're doing this project, it helps if you have a
put it
bucket
aside,
that's see-through.
There we go. See that?
Yeah.
There we go. So I need to drill that. Now, the best way to do this is to get yourself a 1/4 inch drill, a 3/4 inch drill,
3/4 inch
a hole saw.
Okay.
I broke mine.
On one of these buckets?
No.
Oh.
When I was drilling through steel.
Oh. Why were you drilling through steel?
Because I'm an idiot and you're not supposed to do that and don't ever do that. That was a bad idea.
Oh, okay. All right.
Okay. But,
so, wait. That doesn't look like it's going to work well.
it's going to work-ish.
Do you want to try? Do you need me to hold the bucket while...
No, what I need you to do is I need you to comfort the audience as I try to do this. It's going to get everywhere. It's going to get messy in a sec.
Okay.
Yeah, you may want
My
to...
laptop.
There you go. Okay, here we go. All right.
There's going to be plastic particles everywhere.
All right. See, Brian, the trick to drilling through something with the wrong tool
Yeah?
is to pretend like you don't know what you're doing.
Right. It's all about persistence, right?
Persistence of memory, persistence of vision, persistence of the fact that I'm doing all of this without safety goggles, which is a huge no-no in the maker community.
And I'm standing right next to you without safety goggles as well.
So kids, if you are watching this at home, what you're going to want to do is don't do anything that I'm doing right now.
I'm going to see if I can get close up. Oh my. Oh, look at all that sweet plastic.
Oh gosh, it's everywhere.
Yeah, right? Do we have like a little vacuum or something?
Burke!
We're making a mess.
Someone call OSHA.
We need an adult. We need an adult.
It is literally everywhere. Okay, and the problem with this...
That's fine.
Ooh.
Continue. Right on the floor.
It was like that. When
Nobody saw it. It's okay.
They're doing new screensavers here in the
Yeah, they're
aren't
busy.
they? Okay, never mind. All right. This is probably not going to fit because I only did it for the... Actually, hey, look at that. Look at that, huh?
Not bad.
It's kind of... Oh, Burke's looking at me now. Sorry, Burke.
Oh, you can see us through the porthole.
Burke, do we have a vacuum?
Hey, Burke.
Sorry.
We're Burking in here.
He's really not happy.
No. I do like that you did it over the let's do this in the hole.
Oh, why not use a cylindrical drill bit? No, I think we've covered that. That would be the smart thing to do.
Right.
I have a hole saw. I
we
just
said
broke
we were
it.
going to be dumb.
Yeah.
Because Padre broke it,
Yes,
his
but
already.
Burke has one.
Okay, see,
Probably.
I just
Oh.
sorry for the noise.
Sounds good.
Oh, stop! It's good for you.
Everywhere.
You know, the problem is people don't get sick enough, and I'm helping them get sick.
Right.
What?
Shouldn't you have put one of these on there
Well,
first?
it's not forever. It's
Oh,
just
okay.
for now. Come on.
Is
Okay.
it?
All right. So what we need to do is we need to clean this off.
Uh-oh.
Oh.
Burke.
Hi, Burke. Burke, something happened to our set. There was all this plastic residue. I don't know where it came from.
It looks like Garfield shed it over here.
That's not a 3/4 inch hole saw, Burke.
It's bigger. It's better.
Hey, Burke, there's all this stuff on the floor.
We don't know what to do about it.
Sorry about that. So gonna get in trouble for that.
This is the worst episode of this whole house ever.
Okay, so now we've got our hole. Let's go ahead and make sure that these match up. Like that.
Yeah.
And like this. So I got my interior, I got my exterior. That's just about right. That's what I want.
We have made Mr. Bucket.
We have. Now I should mention though, notice how it stood off a little bit from the bottom of the bucket?
Yeah.
That's because on the inside of the bucket there's actually a little lip at the bottom.
Oh, right.
And I needed it high enough so that the valve would clear that lip, because otherwise it would be slightly tilted, and that's when you get bad things.
Cool.
Now, if I was doing this right, I would give this a thorough cleaning, because I don't want any of those particles to be inside of my sealed area. But
Do
I'm
as
not
we
doing
say,
it
not
right.
as we do.
Right. So
because we're doing this live.
we're doing it live. This is all live, folks. And so what we've got is we've got this. This is our handy dandy sealant. Same sealant, actually the exact same sealant that we used from the project to do our little aqua base.
Oh, right.
Right, when we had to seal the top. So we're going to use it again. Wow, this plastic is really Seriously, this is probably not
Looks
good.
like we murdered Garfield in here.
I'm sorry, John. All right, wait, hold on. Oh, hey, you know what? You know what else the 3D scraper is good for?
Sweeping up all the plastic bits.
Sweeping up all the plastic bits.
Yes. Or do.
Just put it back in the bucket. Wait, that was stupid.
Nah, no, it's fine. That's what vacuums are for.
All right. So what we're going to do is we're going to put a thin film of sealant on both sides, and then we're going to compress them together with this.
Right. And typically you'd wait 8 hours before applying water or anything?
Well, this is quick sealant, so you could do it within, I think it's 8 minutes.
8 minutes, okay.
But the longer you wait, the stronger it gets. So I waited 12 hours.
Okay.
Because I don't like leaks,
right.
Especially near my electronics. That's a thing. It's just me. I'm funny like that.
That's weird. It's almost like you've had bad experiences in the past.
Oh, sorry.
You look like you fought with a Cheeto and lost.
All right, so we're gonna go ahead and set these down, and we're gonna spread out a super thin layer. We're actually gonna need napkins.
Napkins?
Yeah, it's gonna.
Is that what these are here for? Did you think ahead, or is this just random stuff that was
No,
back here?
I thought ahead. I thought,
Napkins. You want me to run into the kitchen?
Yeah, grab some paper towels or something.
All right, I'm walking off set.
This is. Folks, this is why you think through all your projects before you actually put them on the air. But if you go to the overhead shot, I'm
just gonna grab the whole roll.
Yeah, he changed that one. I'm gonna go ahead and lay down just a bead on both sides, and then I'm gonna flatten it out just with my fingers. There we go. Look at that. Oh,
Look at what?
so much sealant. It's everywhere. Oh.
Well, I leave the studio for what? 30 seconds? And what has happened in here? This is disgusting.
Like cake batter. All right, there we go. Okay, obviously that's probably not going to stick so well.
You sure? What makes you say that?
Let's do this just so that we can get slightly away
not
from
on the mat?
Yeah, there we go. And then don't do this. Use gloves.
Why are you not using gloves?
Because the main effect of this is it can make you sterile, and I don't really care.
You already have had that problem,
it's cool.
right?
It's all good. Yeah, it's all good. Go ahead. Let's rock. Okay,
Wow.
and so when I do tighten this down, anything that I have left is going to squeeze out, except for the material that's going to fit into those ridges that I created.
That's got some strong smell to it.
It does. Again, if you want to have kids, probably don't touch this.
Is it bad to be in a confined space with no ventilation right now?
Yeah,
I
actually,
feel a little
yeah.
dizzy.
That's not great. It's not the best thing for you. Okay, I'm going to put a little bit on the inside and the outside again because I want to give it the best chance of sealing, like so.
That's such a rough edge.
Folks, here on Know How, we know ghetto products. We're down with that. Okay, all right. So,
Okay.
can you give me another?
You want another paper towel there?
Yeah.
Here you go, buddy.
Okay, here we go. So you go ahead and place the outside seal. I'm going to place the inside seal.
Okay.
So that one. Remember, the larger side goes to the bottom.
Yeah. Wait, larger side goes to the bottom? Okay. Yeah, that makes sense.
And for the inside, the larger side goes to the top.
Are we lined up?
We are lined up-ish. There we go. Okay, and so what I'm going to do is I'm going to go and smooth out on the inside here. I'm actually going to take the excess silicone that's being squeezed out, and I'm almost like making another gasket on the inside.
Right. Okay.
So.
Everywhere.
Wait, did you touch the sealant?
No.
I told you not to.
No, I'm all right.
You might still have kids.
Yeah, I think I'm sterile now. After this episode.
Dang it. Sorry, Charlize. Sorry. Oh my. All right, here we go. So we're gonna put this like so. There we go. Okay, and then put that seal.
It looks like there's a concave side on that, or does it matter?
No, it doesn't matter.
Okay.
And then give me the, where's the nut?
There. And it's righty-loosey, lefty-tighty.
Ta-da! Ta-freaking-da. Now, as I tighten this, you're gonna notice that
What?
it's gonna see how it's squeezing out the silicone.
Yes.
That's good.
Oh, okay.
We want that. Actually, here, you tighten it. I'm going to hold on the inside.
Come
on, Brian. Show me what you got.
Show me what you're working with.
Yeah, probably easier if there's a tool. I think that's about as tight as it's gonna get. It hurts.
Okay. It hurts. Okay, and then what we're going to do is we're just going to take the excess here, or I'm going to take the excess, and I'm going to run it along the outside and essentially smoothing it out and making like another seal, just in case. I'm not saying my workmanship is bad, but yeah, my workmanship is bad on this one.
And you feel bad.
And I should feel bad, like Smitty. Remember, folks, Smitty says your work is bad, and you should feel bad. And I'm going to do the same thing on the inside.
But we're learning, I think.
Ow. Yeah. And the whole idea is I'm just giving myself as many chances not to have a leak.
Right.
Yeah. But the way
just like in life.
the way it's been designed, though, is once this hardens, I should still be able to take this valve out because there's nothing we've done that's like cemented that inside of here. Ooh. So if I wanted to replace the valve with a different size, let's say I wanted to narrow it so that I could use a smaller aperture so I don't get so much water when I open the valve, that's still all very doable.
Okay.
Okay. And there we have it. So this is our bucket with valve.
Nice.
Yeah. This whole thing, again, the most expensive part is that bulkhead fitting. That thing is going to cost, between $10 and $14 depending on what size and what kind of material you want. The 3D parts, we make that design available for you in our show notes. And the solenoid we're going to install in just a little bit. Okay. Now, when we're done with this project, by the end of today, which will be fully functioning, we will have spent about, let's say, $25 including the bucket. So everything is going to cost about $25, assuming you have something like a Dremel that you can drill, assuming that you have some kind of silicone sealant, and assuming that you have some sort of power source, which if you're a maker, you probably do.
Yeah.
But if you wanted to get something right away, there was actually a device that we looked at not too long ago, about 3 or 4 months ago on Growduino. It's a Klaber that allows us to do essentially what we're doing here, but for a little more money. So if you do want to have the Growduino, but you don't want to have to go through all the trouble of actually making it, here's your solution.
So, you've got crops, and you've been a good farmer. You pH balance your water, properly schedule your feeding, keep your grow area clean and healthy. You even sing to your plants. And we're talking smooth jazz, not that hippity-hop stuff that all the kids on my lawn blast at odd hours of the night. You've done it all. But you find yourself in need of travel, and your plants can't live through the trip. Sure, you could ask a friend to water, and if you're not going to be gone for too long, you could do a deep watering and hope your plants can last before you get back. But the last thing you want to do to crops that you spent so much of your time on is to stress them. Friends don't always treat your plants the way you would, and drowning your roots by leaving them in standing water isn't really an option. What you need is an automated irrigation system for an indoor grow. This is the Klaber 8053 Automatic Drip Watering System. It's a 6.6 gallon container with a programmable timer that can water up to 20 plants for up to 40 days, and it does it for less than $100. Out of the box, the Klaber comes with 33 feet of PVC hose, 20 drippers, and 20 spikes. The construction of the unit is pretty simple. Most of the 8053 is a container for the water, while the bottom panel hides a solenoid valve and the electronics for controlling water flow. Setup is simple. Add a 9-volt battery to power the timer and solenoid, then find a way to mount the Klaber at least 2.5 feet above the ground and 1.65 feet above the tallest pot. There are 2 outlets on the unit, which will be connected in a ring with the PVC tubing and the drippers. Set out your plants as you want them arranged, then put a spike into the soil of each pot. You want the spikes to be as level as possible. Avoid going up or down with the tubing as much as possible, and if you must, put the lower pots towards the side of the ring away from the Klaber. If you don't take the time to do this, water may not make it to some of the drippers. Once you're satisfied with your spike setup, it's time to add the tubing and drippers. Start by connecting one end of the tubing to one of the outlets on the Klaber. Now run the tubing around the ring, securing the tubing into each of the spikes until you've reached the second outlet on the Klaber. Be sure to not leave so much slack that the tubing droops excessively. If it does, you've just created a section of tubing in which the water will pool, possibly obstructing your water flow. With the ring complete, it's time to start snipping. Cut the tubing before each of the spikes and add a dripper assembly. Make sure the dripper is positioned so that the water will drip into the soil while not touching or directly dropping water on a leaf. You want to promote growth of the plant, not mold. Repeat the process for all the plants in your ring. Once all your connections are snug, make sure the programming switch is set to off, then fill the Klaber with 6.6 gallons of water. Now we need to bleed the system to remove the air from the tubing. Those bubbles will restrict the flow, making watering uneven and unpredictable. Flip the selector to 10 days, then disconnect the PVC from one of the drippers. Hold your finger over the dripper outlet and let the water flow from the disconnected PVC tubing. Wait until you get a steady stream of water from the PVC tube, then cover it with your finger and release the dripper outlet. Once again, wait until the flow is steady, then reconnect the PVC tubing to the dripper. Your system is now air purged and ready to deliver a constant measure of water. Speaking of measure, we need to say a few things about the programmed watering. The Klaber has 4 options for watering: 10, 20, 30, and 40 days. However, that number is entirely dependent on the number of drippers you have installed. If you select 10 days, the solenoid valve will open for 12 minutes twice a day, delivering 2 ounces of water each time per dripper you have installed. If you've installed 10 drippers, that comes out to 40 ounces a day, which means our 6.6-gallon reservoir will empty in 21 days. If you select 40 days, the valve will open for 3 minutes twice a day, delivering half an ounce of water per dripper each time. If you've installed 10 drippers, that's 10 ounces a day, which means our tank will be empty in 84 days. If you need more water for a larger plant, you can always install multiple drippers per pot. One last bit on your to-do list before you leave for your travels. Before you depart, switch the program selector to your desired watering schedule and look at each dripper, making sure that the water is flowing and that it's going into the soil. Also, it's probably not a bad idea to make sure that you have some sort of overflow protection. The last thing you want is to come home and find out that you've been watering your carpet for 2 weeks. In any case, if you need to be away from your crops for an extended period of time, at least now your plants will have a fighting chance.
The thing is that Klaber is going to cost you $90 to $100.
Right.
And it's a 5-gallon drip system, which we can make in its entirety for about $30.
Yes. This is the maker option.
This is the maker option. Now, this is not the same bucket. This is actually the one that I did last night. So this is all sealed up properly.
Right.
One of the things that we do want to do, though, before we put our solenoid valve in here, is we're going to want to use a little bit of Teflon tape, because when I tested, there was no leaks from our gasket here.
But from the spigot?
From around the threads.
Yeah.
So again, what we want is, we've got an arrow at the bottom here that tells us it's going to go from here to here. I'm going to want to put a little Teflon tape around here before I go ahead and screw it into our bulkhead.
Makes sense.
This is what the Teflon tape looks like. It's literally tape that's made out of Teflon.
If you've ever attached like a
plumbing
shower, a shower head is what I had to do, and I used that.
Yeah. This just gives you a little extra something to make sure. Actually, here, can you hold that real quick? Okay. Just so that it makes it nice and tight. So when I do screw this in, it's not going to leak between the threads.
It's almost like a gasket for the threads.
It is. So here we go. All right. And ta-da! If I can get it lined up.
And just like that, it works.
Padre cross-threaded it. Yeah, thank you. There we go. You know what we need for this, though, Brian? In order to show that this thing is actually working, we're probably at some point going to need to fill this thing up.
With water?
And that's the danger zone.
That would be, I mean, there's all these electronics around us.
Too bad we don't have any water.
Where would we get the water from?
Oh, wait, we do. That's right. Hey, Brian, fill this thing up. Okay, not like that. Fill it up with water, please.
Right. No problem.
I probably should with my laptop, but you know what? This is know-how. This is, yeah.
I got this.
All right.
I got
it.
Oh, bloop, bloop, bloop. Splash zone.
Splash. No.
I got it. You think it's enough water?
No, put it all. More, Brian. More. Everything.
Got it.
Okay. We're even now.
Did I get you?
A little bit.
Oh, sorry, you're in the splash zone.
No, it's cool, man. It's cool. It's all good. Just remember next time I'm gonna electrocute you. So just like before, we're gonna hook up our leads. This has already been preset for 12 volts. If we did our job right, first,
which we probably
you'll notice there's no leaks. So this is good. We like that. And the bucket's nearly full, so this is about the highest pressure I'm ever gonna get on that gasket. And as long as I'm providing at least 3 PSI of pressure on the inside of that valve, it should open when Brian hits the switch. So,
Hey,
Brian, you want to go ahead and flip that switch? There we go.
Oh, we've sprung a leak.
We have sprung the leak.
That's awesome.
Yeah, see?
And
And
close.
then close. And open.
And open.
And close. And open. And close.
It's like a failing prostate. No?
Oh, yes.
Look at it go.
Okay.
That's awesome.
Now, ultimately, if you close that off, what I'm going to want to do is I'm going to want to go ahead and put on a fitting like this. Now, this I just got from the irrigation aisle of Home Depot. And what this is going to allow me to do is it's going to allow me to like hook up a drip system.
Ah, yes.
Oh, come on. Get it. There we go.
You know, there's a trick.
I'm not, yeah.
If you spin it the opposite thread.
Oh, and then wait till it clicks.
And then go. But this is difficult, you're right. Nope, there we go. Nope.
Oh, come on, Brian.
That's what I get.
Show me how to do it.
Oh,
Come on.
all right,
I think you got it.
Like,
yeah.
no.
No, you missed.
The end of this thing is terrible.
Well,
Okay, there we go.
It's
You just
tight.
need to put a little more pressure.
There we go. Okay. And yeah, that should be enough because we're not
Okay.
we're not going to. And it should increase the pressure because it's decreased the diameter. So I'm going to do that a little bit. And Brian, hit that switch.
It's extended.
There we go. Well, actually, it's not that much more pressure. But again, it's still going to be a gravity drip system. But here's the cool thing.
What's the cool?
We're doing it with this 5-gallon Home Depot bucket. You can use anything.
That's
In
true.
fact,
Yeah, you could have a bigger bucket.
I just got a 50-gallon drum that I'm going to try this with. And that's much more doable. It's a much better system. And what we're eventually going to do, this is why this project is going to take so many episodes, we're going to have one source for pure water. We're going to have one source for the nutrient solution. We can also have one source for like supplemental nutrients.
Right.
And I can, with just some programming, I can decide exactly what kind of ratios my plants are going to get.
That's
You're
cool.
really enjoying that.
This is fun. It's got that, I don't know, tactile feel of like I hit the button, something happens.
Okay. Now, in the next episode of Know-How, we were going to go through it on this episode, but unfortunately, we're running out of time. We need a way to control this with an Arduino, and there is one big problem. Do you know what that might be?
No.
Voltages.
Right. So
This-
what are we gonna do with that?
This is driven by 12 volts, and it's a decent number of amps. I can't get that out of an Arduino, so it's not like I can hook the Arduino straight up.
So we have to do like a separate UBEC or something like that?
Well, we could do that, or we could use some relays. We're going to be going into relays on the next episode, along with integrating this with an Arduino, just so you can get the basics of control for your Growduino.
Cool. All right. I'm looking
that's what
forward
we
to
do.
that.
And also, don't forget that as we're doing this project, we're showing you one way to do it. We're showing you with this Home Depot bucket. We're showing you with this valve. We're showing you with a couple of attachments that we want to put into our garden. But ultimately, what we really want to do is we want to give you a template for making your Growduino any way that you want to. And that including sensors. For example, this is pretty much the same setup that I used when I made a kegerator. Because this valve will actually hold back the pressure of a keg.
Whoa.
If you pair this with a flow meter, so it actually knows how much liquid is flowing through the valve, then it means that you could say, push the button and it gives you exactly 8 ounces of beer, or exactly
that's
16
awesome.
ounces of beer.
That's really cool.
Right, so this is one of these projects that we're going to reuse the basic pieces over and over, because all it is fluid moving from one place to another. And think of all the different places in your maker shop that might be useful.
Where you can put all that fluid.
Oh,
What?
you know, on that note, I think we should probably end this episode.
This was a fun episode. This was a good one.
This was, yeah, I mean, this is the sort of stuff where, remember when Smitty came on to do the steampunk Arduino clock?
Yeah.
His thing was, look, find a problem, fix a problem.
Right.
This is actually a problem that I've run into, which is how do I water my plants when I'm gone and I don't want to spend a crazy amount of money to do it.
Yeah.
Well, now I can. And since I'm going to tie this into an Arduino, it's not just the Arduino turning it on and off. I can put moisture sensors on the Arduino. So, for example, put it in the plant, in the pot, and it knows, well, only turn it on if it actually needs water.
That's a smart system.
I can put them on around the perimeter of my grow tent, so if that detects moisture, shut off the system because it knows there's a leak. I can tie it to things like the temperature of the water, which buckets am I dispensing.
Yeah.
This is why we like this backbone, because ultimately what they're going to do is they're going to take what we've given them and turn it into something we haven't seen before, and that's exciting.
That is really neat, especially too if you were putting sensors into different plants and you notice that other ones are getting drier before a certain batch, and then you could just have the Arduino open the valves for a certain amount of plants and not the other ones that don't need it and stuff.
Yep.
Oh, that's really neat.
Yeah.
I like
so
that.
we're going to get crazy in know-how coming up. Now, folks, we know that this was a lot of information. If you want to know anything about this episode, where we got the parts, the individual pieces that we pulled, and the actual process, which we just showed you, so it's not that hard.
Nope.
But it will get more and more difficult as we go into the Growduino project. Don't forget, you can always find everything at our show notes, where do we have those, Brian?
Those are at twit.tv/KH. And yeah, like Padre said, you'll find all the links to the parts that we used today. And also for this project, if you haven't already, you're probably going to want to subscribe because then you will not miss an episode.
Precisely. And if you really want to participate in the community, don't forget, we've got a very lively community on Google+. Just go to Google+, search for Know-How. We've got a little bit of a joining process. It's going to take a couple of hours for me to approve. That's just to keep out all the spam accounts.
Got to moderate.
Yeah, got to regulate.
Keep them moderated.
Whatever, keep it tight.
Exactly.
Exactly. But once you get in, you're going to have access to 11,000, almost 11,000 Ketas. That's our know-it-alls. People of at all points of their know-how journey, experts, intermediates, and beginners. So if you've got a project, if you've got a problem, if you want to answer questions, please join us and become part of our know-how community.
But that's not it, Padre.
No.
There's more. And not just our Twitter handles, which I was totally going to jump into until, who said that? Halo Chart in the chat reminded me the Twit survey.
Yes.
Yes.
Folks, this is the time to be heard. If you like know-how, if you want to see more projects, if you want to move to 3 or 4 episodes a week so we can really kill Cranky Hippo.
Tell them who your favorite show is.
Tell them who your favorite show is. Tell them what your favorite episodes are. Just go to the Twit survey at twit.tv/survey. If you go there, it's the best way for you to actually have direct input as to what we focus on on the network.
Definitely. But if you want to see what we're doing behind the scenes, see what kind of crazy antics we're getting to in the office when we're not on Know-How, as if this show wasn't weird enough, you can follow us on Twitter. I am at @cranky_hippo.
And you're going to find me at PadreSJ. And you're going to find the third member of our crew, our director, Mr. Alan.
There he is.
Alan Parsons.
He gets a little excited sometimes. He gets a little nervous.
Aww.
At ANLEF.
Oh, you know, sometimes when you get older, that happens.
That's true.
Yeah.
He's pretty old now.
You can find him at ANELF3, as Cranky Hippo said. Yeah, let's just let it run until it floods the know-how set. Until next time, I am Father Robert Balaser.
And I'm Brian Burnett.
And now that you flow how?
Go spigot it? I don't know. You stole my flow how. I was going to say flow how.